Hello, and welcome to this webinar. It will be about DraftSight for PCB designers. My name is Jan Keeley, and I'm with the DraftSight team. I actually been doing PC board designs for many years, which I'm not going to tell you how many years. You can probably tell by my gray hair. But what has that got to do with DraftSight? Well, let's see. I wonder if you can identify these images on the screen. Starts out with the TV, then there is a toaster oven, a car, a smartphone, massage chair, and a laptop. What do they all have in common? Well, here's the big surprise. They all have PC boards inside them, which makes the products being electrified. So you may ask, what is a PC board? PC board stands for the printed circuit board. It is, probably you've seen it before, it is a green rectangular, maybe odd shape where the electronics components are attached to, soldered to, with the connectors and wire harnesses that makes the connection to the outside world, and they actually make everything work together and make our lives easier. So what are we going to be covering today in today's webinar? Well, we're going to start with the board outline in key components and mounting holes connectors. Then we'll look at the complex board outlines and why PCB software is not meant for the drafting. Then we'll look at the RF shapes and membranes push switches. Then we'll also look at the complete PC board placement review and documentation and manufacturing notes that entails documenting the boards for manufacturing. So buckle up and let's go. In scenario 1, we're going to look at starting the board outline and key components and mounting holes and connectors and how we can get them into the PCB layout software. The reason is that PC board layout does not just start from a blank page or arbitrary board outline, mounting holes, connectors. Mechanical engineer somewhere started the board outline, how big it is, and where the mounting holes and connectors should be that interface to outside board. Why should we, as a PCB designers, not be able to use this information? And that's where the DraftSight and DXF comes into play. Here is the drawing inside DraftSight, and the board outline is clearly visible with dimensions, and it has the location of the two connectors that we're going to be placing inside the board layout. Also, there is an area that says limit the height to 5.5 millimeters. Also, it has the mounting hole locations that we need to place while we're doing the board layout. So again, we can reuse this information by exporting that as a DXF. I'm going to let you on a big secret. Software like Cadence, Allegro, Mentor from Siemens, and Altium Designer, it is so much easier to get that information in via DXF without trying to recreate this information over again. And this is a fairly easy board outline to make. In a second, you'll see why it can be a very complex. But more importantly, what I wanted to show is layers. So if you create for one specific PCB layout software, create board outline 00 layer. And when you create inside your software this board outline as a closed polygon and place it on this layer, when you import the DXF inside PCB layout software, specifically in pads layout, it will automatically become an intelligent board outline. And all you have to do is basically place mounting holes in the location that they're shown here. Let me zoom in so it's easier to see. So you will place the mounting holes in these locations, basically using this board outline and whatever you brought in from via DXF as your template. So you don't have to guess, and then later, of course, you can measure it. And again, this board outline will become an intelligent board outline inside your PCB board layout software. So we've talked about a very simple board outline with dimensions and mounting hole locations and some connectors. But what if you have to deal with the very complex board outline? PCB software is not really meant to do very complex board outline. It is designed to do a very complex PC board layout with multiple layer routing, high-speed rules, and etc. So how do you deal with that when you have a complex board outline? Well, what if you have a board outline that looks something like that? Let's examine this particular scenario again. Here's this board outline. Now, if you had to create that inside your PCB layout software, no matter what is it, Cadence, Zukin, Altium, or PADS, you will have a very hard time because it's just not designed to be able to handle this complex board outline. But here is in green is the board outline, and in here is even a cutout that we might have to have inside our board so we don't place anything. So why is it easier to do it inside mechanical software? Because it is designed to do this particular type of shapes, not PCB layout. But again, if you go back into layers and take a look at some of this information, you'll notice that there is a board outline, board keep out, part, PCB parameters. So if you include even some keep out information for these specific areas in this layout, again, they'll come in via the DXF export. Let me do this. Save to this PC, and then you can export that not as a DWG, but as a DXF. You can do different versions of DXF going all the way to revision 12. And then once you create that file, you'll be able to import that file inside software layout designed for PCB. And I guarantee you the PCB designer will be very thankful and appreciative because he doesn't have to create this very complex board outline inside the PC board layout software. All he has to do is concentrate on actually making layout, connecting, changing the continuity of this design, and not worry about creating these complex shapes inside the PC board layout software. Now we're getting to the fun part. RF shapes and membrane push button switches and some specialized things that can be done inside mechanical software much easier than it can be done inside the mechanical software. So here's the membranes. There is some RF shape and RF layout. So how do we deal with that inside DraftSight to help our colleagues on the PC board layout end of it? Here again, we're inside DraftSight, and you see this very funky shape, almost looks like a snail. Or another one. What are these? Are the push buttons or membrane switches that can be included inside PCB layout. And I'm sure you know what I'm talking about. If you use any kind of a washing or drying machine or some other equipment that you just press a button. Even older iPhones, they had that button, which is really a membrane like this. Now, if you think this is hard to design, hold on a second. We'll get to something even more complex. But if the PCB designer had to create this complex shape inside PCB layout, they will literally crawl in a corner and cry. And that's why they are very appreciative when we can create them for them, and they can import it as a DXF inside the PCB layout. Now, again, Why is the layers important? So if you put this on layer 2, which is green, this copper shape for that complex membrane switch that can be used to create a component inside PC board layout is going to end up on layer 2 as a copper solid snail piece or the rotation. Now same thing for the membrane switch. Now you think this is hard? How about something like this? Let's go and look at our sensor ring. Let's zoom in, and now you'll see what I'm talking about. If you were a PC board layout and had to create this complex shape for the switch, right? So you remember like iPods, when you kind of rotate with your thumb and it pushes it and makes the contacts. Making that inside PC board layout is not a trivial thing. It might take you weeks to try to create something like that, where you can create it very quickly inside DraftSight mechanical software, and again, export it via DXF for import into the PCB layout software. Again, there is a lot of layers that you can set up depending on software you're using, and knowing what those layers are, you can right away put specific entities on intelligent layer, so when you bring it into the PC board layout, they end up on appropriate layer and possibly even as a solid pieces of copper that you can use to create a symbol for this complex switch inside PC board layout. Believe me, you'll understand why it's so important. Now, for people that do the RF design, that's even more important. Let's look at the RF shape, okay? So in RF shapes, if you are RF designer, believe it or not, the way this chamfer comes to the sharp 90-degree corner, the closer or farther it gets, it actually tunes the circuit for specific frequencies. So this shape has to be exactly, there is no variation. Cannot be even 0.01 of millimeter differences on these distances. So this can be created again inside mechanical software and imported inside the RF design. And now let's take a look at the RF design that will show up in a second, and I'm going to zoom in into a certain area. And I turn off some of the layers in this layer. This actually has a lot of layers, drill information and so on. But now imagine try to create this complex shape inside the board layout as a copper piece with the very precise, let me zoom in even closer, distance between this 45 and 90 degrees is very complex. And now some other ones, this is like tuning circuits for RF design. So people who design RF boards will immediately understand what I'm talking about and appreciate that we'll be able to bring this in via DXF as a complex shape inside layout, and they are really end up on specific layers, and automatically you can create board layout for this specialized application RF design. Not a trivial thing to do if you don't have DXF import inside your PCB layout software, but if you do, it saves you ton of time. So, believe it or not, this is a must thing to have for PCB layout. Just for fun of it, I'm going to show you on a project that I actually had to design a long time ago. And let's go and create a P line or poly line. Let's start right here. I'm just going to do a couple more lines and just stop here. Okay, very simple, right? But what if I have to now convert this into an arc? Is basically was like a head of a Mickey Mouse, and we created like a proximity sensor. It's called electronics leash. So the parents would wear a receiver and the child will have this Mickey Mouse pin with the battery, which if the chunk wanders off like 5 feet or 8 feet, which can be programmed away from the person who's holding the receiver, it would start beeping so the person can start looking for their missing child. Now again, this doesn't seem like big of a deal, but again, try to create this complex shape inside PC board layout, and you'll know that it's not a trivial thing to do, and that's why you appreciate being able to do it inside mechanical software and bring it as a DXF again. I may sound like a broken record, but believe me, this saves you tons of time. Another aspect of documenting inside PC board layout is you don't want to create this template inside the PC board layout which have your company logo, and other like standard notes. So you can create those templates inside, again, DraftSight, and export them in DXF and import them inside the PC board layout, which will actually help you tremendously in doing documentation. So you can have a number of templates for C size, D size, and some other things. And now you'll understand why this is an important thing to have to be able to create this inside mechanical software. And the last scenario we're going to examine is when you have a PC board layout, how do you communicate and review the placement? How do you look at some of the routing? And how do you finish your layout? So let's go and examine this specific scenario. So as a PCB designer, you received the information for the board outline dimensions and you placed some of the components. And now it's time to communicate with your maybe external source that the placement is correct. They might not even have a PCB layout software. So how do you communicate? You don't want to take a snapshots of every layer or everything and send it via email or Word document. It's just not practical. But either export your entire layout as a DXF and give it to them, and they can read it into DraftSight. So I've done a couple interesting things already. I took this DXF of the PC board layout, which this is like basically a control panel that has a lot of the components, and I create what it's called layer states. I have placement. Let's go look at the placement. So this is the placement, and you can zoom in and take a look at it, how certain things are placed. And after reviewing, you may not say, you know what, this battery, coin battery is in the wrong location. So, okay, so what I did, I created a markup layer state. And notice that I can put on this layer, which is, there is a layer that I create markup. Let's see markup, it's in red. And I can say, you know what, instead of telling them, I can put it inside there and say, move this battery by 3 millimeters down. So you can easily communicate this to your layout person so they can move the layout. But let's say besides just that, you want to examine some of the routing that was done. So I created a layer state for routing where I turned on some of the routing layers. How cool is that? Let me zoom out a little bit and move this so you can easier to see. And what I did is I only turned top layer and the bottom layer routing. But if you want to go ahead and review some other layers, trace on layer number 2, 3, 4, 5. So basically all of the layers. And then I turn it on, you see that now you see all of the layers, and you can zoom in and take a look at it, how the routing was done. I actually turned off the VS. So this is actually an entire PC board layout came in via DXF for your review inside the software. You don't need to own a very expensive software for PC board layout, but via DXF, you can look at the placement, you can review that, and you can easily communicate with the PC board layout. And the last thing that we are going to do is documentation. So let's go back into the documentation state, okay? And I'll zoom out a little bit. So we have our dimensions, we have our component placement, but now we want to add information for cross-section of the board and the notes, how to build this board, what material is to use, what kind of seal screen, what kind of solder mask. How do you do that? Well, I created blocks inside DraftSight that has notes and cross-section for this, is it 6 or 8 layer board? Let's find out. So I'm going to say insert block, and instead of attributes, we're going to go and insert nodes, type nodes. And there are the nodes. Oops, I don't need that. So I want to insert this. I'm going to say our cross section. Here is cross section. And here is my cross section. And here, oh, I placed number of them. Sorry, I didn't pay attention. My bad. And now let's take a look at it. So we'll zoom in into this area. This is the 8-layer board with my cross section with overall thickness of the board, and it tells me the seal screen, solder mask, layer 1, planes, and so on. And if I go and look at my manufacturing of this board, you'll see that it says, okay, here's my layers, but we can specify now the part number, revision, what kind of material to use. So basically, what we can do is include all of this information inside the mechanical software so we don't bog down and use a very expensive PC board layout software to do this task of adding nodes, cross sections, title blocks, and you can use that PC board layout software for doing complex auto routing or calculating the delays and interfacing with the simulation software. So you leave the simple stuff for documenting this layout for mechanical software like DraftSight, which is a great help. So I hope you got good information how to free up your PCB layout software to do what? PC board layout instead of doing mechanical stuff for complex board outlines, for RF shapes, for sensors. And you can use that to supplement your design team and communicate with your PC board layout and mechanical systems very easily via DXF.